Welcome back, third graders, to our science lessons. Previously, in Exploration 1, we said that fossils are remains or traces of an organism that lived long ago. By studying fossils, we can know more about once living things. In Exploration 2, we're going to analyze and interpret fossil evidence of organisms that lived long ago that shows the patterns of life in the past. Sometimes it is hard to tell how large an organism was just by looking at fossil pieces of it. It is also sometimes hard to tell a fossil's size from a simple picture of it. Like the pictures we see here on page 360, the first picture shows a giant ground sloth fossil. The second picture shows a cycad cone fossil, and the last picture shows a trilobite fossil. Looking at the picture is not enough to help scientists determine their actual sizes. So, scientists compare their findings with something they are familiar with, like the school bus, for example. By looking at the organisms next to the school bus, you can now easily tell their estimated size. On page 361, number 12, we're going to think of some common objects that can be used to show the size of each of the fossils listed below, which are the ones we just saw in the picture with the school bus. So we have the trilobite, the cycad cone, the utahraptor, and the giant ground sloth. The trilobite is so small, if we compared it to a bicycle pedal, for example, we could say that the bicycle pedal is larger. The cycad cone can be compared to a pine cone, but the pine cone is smaller. The utahraptor is a kind of dinosaur, can be compared to a teacher's desk, for example, but the teacher's desk would be smaller. And finally, the giant ground sloth can be compared to a van, but the van is probably larger. Now it's time for the Do the Math activity. A scientist will often take a picture as part of collecting data about a fossil. To show the size of the fossil, the scientist will place an object with a known length next to the fossil. The object becomes a visual reference similar to the bus. Suppose a scientist uses a 4 cm paperclip as a visual reference. How large are the fossils described below? Fossil A is half as long as the paperclip. Fossil B is 3 times as long as the paperclip, and fossil C is 4.5 times the length of the paperclip. Let's break it down, starting with fossil A. It is half as long as the paperclip. This is the paperclip measuring 4 centimeters. Let's pretend this is fossil A and it is half as long as the paperclip. You know that when we say half, we divide by 2. So let's divide 4 by 2. We get 2. That's right. So in our books, we write 4 divided by 2 equals 2 centimeters. Now for fossil B, it is 3 times as long as a paperclip. Let's pretend this is fossil B. It is 3 times as long as the paperclip, so we can model that by placing 3 paper clips next to the fossil. When we say 3 times, we multiply by 3. So let's multiply 4 by 3. We get 12. That's right. So in our books, we write 4 times 3 equals 12 centimeters. And finally, fossil C. It is 4.5 times the length of the paperclip. Let's pretend this is fossil C. It is 4.5 times as long. So we place 4 paper clips and then a half. We can split it into 2 parts. First, we do the 4. 4 times as long means we need to multiply by 4. So 4 multiplied by 4 is 16. That's right. And then we do the half. Half as long again means we divide by 2. So 4 divided by 2 is 2. Exactly, we did that earlier. Now we add both answers. We do 16 plus 2 equals 18. So in our book, we write the steps we took. First, we write 4 times 4 equals 16. Then we write 4 divided by 2 equals 2. And finally, we add the answer 16 plus 2 to get 18 centimeters. Fossils of entire organisms are rare. Scientists usually only find pieces and parts of once living things. Complete fossils give scientists greater insight into what some organisms used to look like. In your book's page 362, number 14, we're going to compare the details in the fossils, then describe what we can say about each fossil. In this picture, we can see the tail clearly. It is narrow. We can also see the mouth. In the second picture, the bones are easily visible. The eyes and the mouth are easy to see. There are at least 2 clear fins and a tail, and we can notice that this organism is wide and fat. On the same page, number 15, which modern-day animal do these pictures resemble or look like? Which features provide evidence for your conclusions? They look like fish. They have fins and tails, but no arms or legs. On the next page in your books, an artist drew what the original organism may have looked like. Let's compare the images and tell how the art matches the fossil or not. First, let's list the parts that match. We can see that the mouth, fins, and eye are all in the similar locations on the fossil and in the art. However, the art appears to be a little more narrow than the fossil, and the tail appears to be a little longer. In number 16, how does a more detailed fossil help scientists better understand what the organism was like? Well, the more detail a fossil contains, the more information a scientist can gather from it. The more information they collect, the better they can understand what the organism was like. Some fossils closely resemble organisms alive today, like when we compare these two images in Exploration 1. Others, however, look nothing like organisms that live on Earth today. In fact, some fossilized organisms are so strange that it can be hard to imagine what the organisms looked like when they were alive. In your book's page 364, number 17, we're going to match the fossils with the possible organism they might have looked like. Now remember, no one really knows what the soft parts of these fossilized animals look like, but by using patterns that we see, we can predict what the organism might have looked like. The first picture looks round with some sort of spikes coming out of it, so it could have probably looked like this. The second picture is long and with a narrow tail, so it could have looked like this. And finally, this fossil might have looked like this. On the same page, number 18, how do scientists know that some organisms not alive today once lived on Earth? By now, you should be able to say that finding and studying fossils that are nothing like modern organisms shows that other types of organisms lived in the past. Before we answer the lesson check together, let's watch this video.
Rawr! Oh, hey guys, we're just practicing our best dinosaur roars. If you've met my friend Dino before, then you probably know he's crazy about dinosaurs. He loves going to museums to see their bones, reading books about them, and even pretending to be them. Wouldn't it be cool if you could spend all day thinking about dinosaurs, trying to figure out things like, what did they look like, or what did they eat, and do they like to play too? For some people, their job is exactly that. But this special group of scientists doesn't just study dinosaurs. They learn about all kinds of things that lived a really long time ago, including reptiles, mammals, plants, and even teeny tiny bacteria. These scientists are called paleontologists. Now, you probably noticed that the kinds of dinosaurs that you see in museums aren't alive anymore. I mean, you don't have to worry about bumping into T-Rex at the grocery store. That's because they're extinct. They died out millions of years ago. So, for paleontologists to do their job, they have to look for clues that dinosaurs and other extinct animals left behind. Luckily, they left us plenty of clues. They're fossils. Fossils are the remains of animals and plants from long ago that slowly became preserved in rocks. Fossils can be of animals' bones, teeth, and shells, or the imprints of old leaves. Or they can be rocks that hold other clues to what life was like in the past, like an animal's footprint or even their fossilized poop. Paleontologists use all of these kinds of fossils to find out more about the history of life on Earth. For example, they've learned about extinct trees and flowers that lived millions of years ago. They found bones of some of the earliest known mammals. And of course, if it weren't for fossils, we wouldn't even know dinosaurs existed. Paleontologists have been able to make all of these discoveries because they're experts at reading the clues they find in fossils. If scientists find enough bones belonging to an extinct animal, like a dinosaur, they can put them together to figure out what that animal looked like. And if they find the dinosaur's teeth, they can figure out whether it ate plants or other animals, or both. Just knowing where a fossil is buried can give scientists a lot of information too. For example, if paleontologists come across a layer of rock with a lot of the same kind of dinosaur fossils in it, that might mean that that kind of dinosaur lived in big groups. But before paleontologists can study fossils, they have to find them first. And that means that these scientists get to spend lots of time outside digging in the dirt. First, they go to areas where they think fossils might have formed and start exploring. They keep their eyes open for small bits of bone sticking out of the ground or rocks with cool shapes on them. Riverbeds and hillsides are especially good places to look. Once they find a promising spot, it's time to get digging. Paleontologists use picks, shovels, even big diggers to unearth their finds. If they uncover a fossil, then they take it back to their laboratory to study it. There, they can use cool technology like X-ray machines and CT scanners to see inside the fossil. And they can use computers to help them see what the plants and animals may have looked like when they were alive. And finally, paleontologists spend a lot of their time sharing their discoveries with other people. Lots of paleontologists work with museums and schools so that they can teach people like you and me about fossils that they find. And the fossils are usually kept in museums or universities, so other scientists can study them too. All told, digging in the dirt and dreaming of dinosaurs may look like fun, but paleontologists have a really important job. Together, they're working to solve a huge puzzle, the puzzle of life on planet Earth. Every new fossil is another piece of the puzzle, helping us to understand how plants, animals, and the Earth itself have changed over time. And you know what? Many paleontologists say they got into their special kind of science because when they were kids, they loved dinosaurs just like we do.
Yeah!
So keep dreaming and practicing your best dino roar, and one day, it could be your job too. And if you'd like us to dig up some more information about anything, just let us know by leaving a comment or emailing us at kids@thescishow.com. Thanks for joining us on SciShow Kids, and we'll see you next time.
See you later!
In your books, pages 367 till 369, we're going to answer the lesson check and lesson roundup together. Pause the video here if you would like to read the questions on your own and try to guess the answers, then unpause to continue. Remember, you can pause the video anytime to copy the answers on your book. Now that you've learned more about fossils, explain what the fossil from the beginning of the lesson tells you about the past. Be sure to do the following. Explain how the teeth give clues about the animal it came from, and describe how the teeth became a fossil. We said before that the jaws are similar to today's great white sharks, so it was probably also a fearsome predator that ate other animals. Comparing the teeth to a great white shark's teeth shows just how large the creature was. Since the organism had a similar jaw to a great white shark, it most likely lived in water too. The teeth probably became a fossil when the animal died, sank to the bottom of the ocean, and was covered in sediment or mud. For number 2, in what type of fossil has once living material been replaced by mineral? Is it A, petrified wood, B, a carbon film, C, amber, or D, a trace fossil? In exploration 1, we said that wood gets replaced by minerals, so it becomes petrified or hardened. So the answer is A, petrified wood. In number 3, we're going to circle the answer that best explains why the object in this image is a fossil. Is it A, it has no soft parts, B, it was dug up by a paleontologist, C, it took a very long time to form from a once living organism, or D, there are similar shells on Earth today? For the fossil to form, it needs a very long time, so the answer is C. In number 4, we're going to circle all of the phrases that describe a fossil, so you might have more than one answer. Is it A, woolly mammoth frozen in ice, B, pine cone from a city park, C. Impression of a leaf on a rock, or D. An empty seashell on a beach? There are many ways that a fossil can be formed. Two of these ways are listed above. We mentioned in Exploration 1 that animals, such as mammoths, can be frozen in ice and preserved for millions of years. We also said that leaves can leave an impression when pressed against a rock. So the answers are A and C. For numbers 5 and 6, decide whether the sentences are true or false. Circle the correct answer, then support your choice by writing how you know each statement is true or false. In number 5, the skeleton of a fish that died and became buried in the ocean floor a month ago is a fossil. True or false? The clue here is a month ago. So it did not take a long enough time for the fossil to form. So the answer is false. A fossil does not form in a month. Number 6. All of the organisms that lived millions of years ago are extinct. True or false? Keep in mind that there's a difference between death and extinction. Not all of the organisms are extinct. Some types of organisms that existed long ago still exist today. Now the lesson roundup on page 369, part A. Mark all of the phrases that describe a fossil. A. Muddy paw prints across a tile floor. B. Empty crab shells on rocky beach. C. A butterfly enclosed in amber. D. Imprints of leaves on a concrete sidewalk. E. Dinosaur footprints and petrified eggs. Or F. A fish skeleton floating in a lake. In Exploration 1, we learned that fossils are the remains or traces of organisms that lived long ago. So which of these phrases describe a fossil? I believe you already guessed it. It's C and E. In part B, we're going to choose the word or phrase that best completes the sentences below. We have the following words: extinct, very young, very old, plants only, animals only, and living things. Fossils come in all shapes and sizes, but no matter the shape or size, they all come from blank. Remember the definition of fossil. It is the remains or traces of an organism that lived long ago. So the answer is living organisms. The second sentence says, fossils provide evidence of blank organisms that no longer live on Earth. There is a definition for organisms that no longer live on Earth. It's extinct. In part C, which of these would give a scientist the best evidence about the size of the once living organism? Circle all that apply so we may have more than one answer. Is it A. Fossilized footprints, B. A petrified tree stump, C. A frog trapped in amber, or D. A fishbone? Let's carefully examine each option one by one. A scientist can measure the fossilized footprints and find out the size of the organism from the size of their foot. A scientist can also measure the width of the tree stump and know how big the tree was. Also, when a frog gets trapped in amber, the whole body is preserved, so it's easy for the scientist to measure the organism. And finally, a fishbone, like the one we saw in Exploration 2, can help the scientists measure and predict the size of the organism. So all the options are correct. That's it for this lesson. In the next lesson, we will be learning how fossils can tell us whether the once living organisms lived on land or in water.